All right. Hello, namaste, and welcome everyone. Welcome to this problem solving session. I see no one has joined here yet. Okay. And it has been like 5 minutes since then, since I started this meeting. Perhaps I will just go on and solve all the problems, and maybe if you have some other questions related to this particular assignment or quiz, you can maybe ask those questions in perhaps the next tutorial or problem solving session. Yeah. So so let me add my device to this meeting and share the screen. Okay. So let me just check it. Okay, yeah, so it is visible to me at least. All right, all right. So, yeah. So let me create a uh, let me create where is it? NPTEL, not this one. NPTEL, yeah, tutorial. So this is our third tutorial. Yeah. Okay. So let me just check how much is the. Yeah, so the battery here is a bit low. Let me wait for some time. Okay. Cannot do anything about it. Nonetheless, I think it should not be a problem. Let's see. All right. So yeah, still no one. Yeah, it's a bit drowsy to just speak in front of a screen with no audience in it. Yeah, but okay. Nonetheless, we will get started. Okay. So broadly, the last week three was basically revolving around feed forward neural networks, which are sort of with feed forward network, you sort of jump into the modern era of deep learning. Okay, so till now we were just seeing that okay, how do we come up with solutions to Boolean functions, or or functions which are Boolean, which take Boolean inputs and things like that. Then, so we saw McCulloch-Pitt neuron, yeah. Within McCulloch-Pitt neuron was sort of the most basic uh, neuron that you can think of, like the earliest algorithm that you can think of. But after that, we went a step forward, and we learned about something called perceptron. We saw how perceptron algorithms work, yeah, and uh, uh, we saw convergence of perceptron algorithm, and that was exciting as well. But nonetheless, there were perceptron algorithm again was very rigid in some sense, because you see perceptron algorithm was able to classify points which were linearly separate, and most of the modern world data are not actually linearly separable. They are under some condition, but okay, I mean, let's not get into those things. And broadly speaking, linear separability is a very rigid condition, and it doesn't offer much flexibility. And following that thread, in week two, we saw something around representation power of neurons. So we saw that okay, any functions, any arbitrary function which need not be linear, can be constructed using we can break any function into sort of building blocks, where each building block is a rectangle. And we saw that okay, using uh, uh, sigmoid activation functions, so using sigmoid activation functions, you can actually build these rectangles. And then we saw that okay, if you can construct one rectangle using many such rectangles, you can actually approximate any function to required degree of precision. Okay, so this was week two, and we solved some problems around it. We saw that okay, what are how many neurons are required to construct some function which has 15 steps in it, or things like that. Okay, and then we also looked at some loss functions that we will be using a lot. Okay, so we saw all these things. Okay, the next thing, so week three basically takes a jump from these very basic methods to something which is very modern, and which is nothing but actually feed forward neural networks. So feed forward neural networks in some sense are building blocks of what today's deep learning, to modern deep learning. and it is extremely important that we understand it correctly. There should be no doubt when we think of modern day for feed forward networks. So you will keep hearing these words again and again as we proceed in the course. Yeah. So that is the gist of what we have done till now. Okay. Now, from here on, so what I will do is maybe I will take some questions and solve them. Okay. And since none of you are here, maybe you can ask if you have any doubts, you can ask those questions in the next session. If not, we will continue. Okay. Okay. So, all right. So let me start with some questions. Okay. So this will be week three assignment, quiz assignments that we will be solving. So this is week three. Okay. So let us see what it is. Okay. So the first question is the first question says the following. So we have a multi-classification problem. Okay, that we decide to solve by training a feed-forward neural network. All right. What activation function should we use in the output layer to get the best results? Okay, so this is the question, and you have some four options, which are softmax, logistic, zero one function, and linear activation function. Okay, so let us first look at. First, I will tell you like what all are the wrong options, and then we can see the correct answer. Okay, so Revati has joined. So Revati, can you hear me? First of all, just to confirm if I'm audible or not. Hello, Revati. You can tell me in the chat, or you can just speak up. I don't know. Yeah, so let me type just to make sure that I am not doing anything stupid, and I explain everything and then I get to know that I was actually not audible. Let me just confirm that. Uh, uh, I don't know. So no response. Okay.
Yes, you are audible, sir. You are audible.
Okay. Thank you. Thanks a lot. Okay. So thanks a lot. So I was afraid that I'm not audible, and because of that, you are not able to hear. Thanks. So as I was explaining that we will be solving some assignment three problems. So let's carry on. So the first question is basically asks you that if we are given a multi-classification problem and we want to solve it using a feed-forward neural network, what activation function should be used? So let us first look at the wrong options, and then we will sort of see why the correct option is correct. Okay. So there's a one option is logistic function, logistic activation function. Well, how does a logistic activation function look like? Logistic function looks something like this, right? So you have zero here and you have one here.
Sir, sir,
Yeah,
we can't able to see anything. Are you using any kind of whiteboard or anything else?
yeah. I am actually using my tab here. So I have shared my screen. Is it not visible?
But yes, sir, it's not visible. We can't able to see that.
Okay, so let me stop presenting and kind of I will reshare it. Okay.
Okay, okay, okay.
Okay, just let me do that. Okay, share screen. Start broadcast. Okay, now is it visible?
Yes, sir. Yes, sir.
Okay, thank you. So I hope it is visible now. So let me continue. Uh, okay, fine. There's some notification that is. So this is visible, right? Because my screen has frozen. I don't know if it is the case with just me or uh, I am not sure about it. Can you help me here?
Sure, sir. Sure, sir.
The screen is visible, right? You can see the screen moving.
Yes, yes, sir. Yes, sir.
Okay, okay, fine. Then I will continue anyway. Because let me just, just do it one more time so that I don't know what has happened. On my screen, I am not able to see. Okay. Okay, fine. So now I am able to see my screen. So yeah, so we were discussing that which of the activation functions would work best for a multi-classification problem. So let us look at the options. So the second option is the logistic function. So the logistic functions look something like this, right? You have a function that goes from here to here. So this is something. So it is upper bounded by one and it is lower bounded by zero. Okay. And what is the expression for logistic function? So the logistic function is 1 upon 1 plus e raised to minus whatever your f of x is. So this is the logistic function and it looks something like this. So yeah. So why would this not work? Well, let us have a look at it. So we can see that there are so logistic function is actually an approximation to a step function. Step function is something like this. So the classical 0 1 loss is something like this, right? So in some sense, logistic function is a continuous approximation to this function, which is smoothened here like this, and this is your 0 1 function. But I mean, the good thing with softmax function is that it is differentiable, and you can use it to learn some parameters and things like that. However, we can see that there are only two levels that it provides. So it is able to basically discretize between two levels, 0 and 1. If so, in a multi-classification problem, you might have n classes. So logistic functions doesn't provide us n levels. It only provides me two levels, 0 and 1. So I can at max use it for at max uh, use it for what, for binary classification, and not for multi-class classification. So this is not a correct option. Okay. So there is another option which is 0 1 function. So what is the 0 1 function? Again, I wrote it. I will again show it. So 0 1 function is again something like this and this, right? So this is 0, this is 1. Yeah. And so again, the problem still persists, right? You have one level here and another level here. But in a multi-class classification, you need several levels. You need another level here, another level here, another level. That is not available here in some. So again, same issue, right? Let me just copy this thing here that I have written because the argument remains the same. Okay, let me paste it. Okay, and I will just mark an arrow here. Okay. And again, I mean, 0, 1 function is also not desirable because you have a discontinuity here. So it won't be differentiable at x equal to 0. And again, I mean, you won't be able to, efficiently use it. And third is a linear function. So what do we mean by a linear function? So something like y equal to mx plus c is a linear function. Okay. So how would a linear function look like? A linear function would look something like this. So you have your x-axis, y-axis, and something like this. Yeah, some line like this. Y equal to mx plus c type. Yeah, but I mean, the problem with the linear function is that what it is doing is it is so the problem with these two were that there were only two levels, 0 and 1. Yeah, 0 and 1 again. The problem with linear okay, someone is joining. Yeah. So the problem with linear function is that it has too many levels. So this level, too many levels. Yeah. So in some sense, every point on real line it assigns a level. So that is also not desired, because if we have too many levels, I cannot I cannot in some sense use it, because it is too much for me, because I will have some n classes and you are giving me infinite number of levels. That is not useful to me, right? Uh, so in that sense, linear functions are not useful as a for a classification problem, or another way to say it is that I don't have any discreteness here. I need some discreteness. So I need some sort of discretization. So here 0 was one discretized part, 1 was another discretized part. If I threshold the uh, uh, if I threshold the logistic function, I can get 0 as one discretization, 1 as another discretization. Whereas here I have a straight line and I don't know how to discretize it. So unless I discretize my output, I can't use it for classification problem. So let me just write it. The issue with this is first is too many levels. Actually, it's infinite number of levels. And the second issue is that no discretization, no discretization. So these two problems make it difficult for us to use it as for a as activation of a classification problem. So this is also not desired. So the first option, which is the correct one, is a softmax. Okay. So what does softmax do? Softmax is something like this, right? You have uh, f of, so let me call this fo. Okay, and the output is the following. So okay, let me just erase this. Let me draw a neural network. So let's say you have some 2 3 inputs. You have some n number of hidden neurons here, and let's say you have n classes here. Okay, so all of them are connected and things like that. uh, so these are also connected. you you understand, right, what I'm saying, that these are all connected. Yeah, don't make me make all of those. It's too much to draw. Okay, so let me bring it here. And yeah, so the output of each neuron is the following. So let's say if f1, f2, f3, f4 till fn are kind of the outputs that you have. The activation, output of the activation functions would be e raised to f1, whatever your input is, upon summation e raised to fi x, right? This is what your softmax function is. So the for here it would be e raised to f2 of x upon summation e raised to fi of x, e raised to f3 of x upon summation e raised to fi of x. So for nth logic, it will be fn of x upon summation e raised to fi of x, right? So this is what it will be. Okay, so you can see, right, that so actually by construction, softmax provides you n discretization. This is the first level, this is the second, third, and this is the nth level. So I mean, softmax function is actually constructed in such a way that you have n discrete outputs, and you can use these discrete outputs to finally give some predictions. So by construction, it satisfies everything that we need in a multi-class classification problem. So what are the properties that we required? First one was n discretization, n discretization levels, uh, differentiable. You can actually differentiate each function with respect to the parameters, differentiable, and what else? uh, let me write it's perfect, because every now and then we in classification problem it is a thumb rule to use softmax functions. So softmax is the correct answer. I hope most of you would have solved this problem. If you have any doubts, you can just raise your hand, just unmute yourself and ask question if you have any. Okay. uh, so let's move on. Yeah, so if you have any question, you can just ask me. I won't wait for you to ask questions. You can just unmute yourself at any point of time. Feel free and ask question. Okay. So here is the second question. Second question gives you a function which f of x comma y, which is what? Sine of xy into cos of xy square. And they are asking you what is the gradient of f. So before we do anything, we are seeing that there are two things here. One is a sine function and another is a cos function. Okay, cos function. So let us make our basics clear. What is d by dx of sine x? It is cos x. Okay, and what is by d by dx of cos x? It is minus sine x. So these are basic elementary stuff. We should know them. I have written it just to make sure that we know we are on the same page, so that there is no confusion. Okay, so now what is gradient of f? So whenever you take gradient of a function, it is actually a vector. Okay, it is actually a, so yeah, so it will be yeah, great.
Uh,
It will be a vector.
Excuse me.
Yeah,
Are you sharing
yeah, yeah.
some screen? Because I cannot see when you're writing it down.
Yeah, yeah, I am
No,
actually sharing my
we
screen.
can see. Yes, sir, we can see. Ma'am, please check your screen. We can able to see the screen. What he's writing, we can able to see. Ma'am, please check
Yeah,
from the printer.
yeah, maybe rejoin and see if you can see after you rejoin. I don't know. Uh, but on my screen as well, it is visible. So I don't know what is the issue.
So it is visible for
Okay,
us, sir.
okay, thank you. Let us see if so. So is it visible now?
Yes,
Gitika
sir. Yes, the
Gupta.
screen is visible. You are trying to write a matrix, right, sir? Delta F.
I'm sorry,
Yeah,
it
yeah.
is
No, I'm asking.
visible to me. Sorry, it's not visible to me. Rejoined again.
Okay, so let me do one thing. What I will do is I will stop and again reshare. I don't know why this is happening, but let me reshare it again. Okay. So let me see. Let me know if you can see now. Is it visible now? My screen.
Yes, thank you
Yes,
so
sir.
much. It
Yes,
is
yes,
visible now.
yes.
Okay. Okay, fine. So it seems to be a recurring problem. I don't know why it is happening, but okay. Nonetheless, we will continue. Okay, so we were looking at difference. So we were given this function f of x comma y, and we were asked to calculate the gradient of it. So first of all, we need to make sure that we know what the gradient of the function is. Okay, so the gradient of any function, whenever you ask, I hope you agree that there are two variables involved, x and y. Okay, so let me just okay, so x and y. So if there are two variables, you cannot simply just differentiate it with respect to x or y, because there are two variables involved. So I hope you will agree that you cannot simply take differentiation with respect to x or just y. So the idea to the way gradient is defined for a multivariable function is that you take the gradient first with respect to the first variable, which is x in this case. Then you take the differentiation with respect to the second variable, which is y, and you stack them in a vector. Okay, and this vector will be actually your gradient. Okay, so again, I mean, what does it mean that I take the differentiation with respect to x? What it means is it is actually a it is just a notation, but we should be clear that what we mean by stuff. Okay, so I hope this is clear. Writing this thing is equivalent to this, writing this thing is equivalent to this. Okay, so let us now calculate each of the elements. Okay, yeah, so let me calculate it. So del by del x of f. So this, I hope you know that this is del. This is pronounced as del. Okay. Okay. So yeah. So okay. So the thumb rule when you have to calculate partial differentiation is simple. Okay. What is the idea? Every term in your function is constant except x. Okay, so y will be a constant here, y will be a constant here. However, x won't be a constant. You will be differentiating it with respect to x. Okay, so let us try to write down what will the function be. So, so it is multiplication of two a sine term and a cosine term. So you will use the product differentiation of products rule. What is it? So del by del x of, let me just write it. Okay, I mean these are very basic elementary stuff. However, I will go over it very quickly. So what is it? So del by del x sine. You will first differentiate the sine term, okay, and you will keep the cos term as it is. Then you will add. What will you add? You will keep the sine term constant xy, and you will differentiate the second cos term del by del x cos of xy.
நீயும் ரெஜிஸ்டர் பண்ணிருக்கியா ஐஐடி ரூப்பர்ல? ஐஐடி ரூப்பர்ல ரெஜிஸ்டர் பண்ணிருக்க தானே? டீப்ல
Sorry, are
ஓப்பன்
you
பண்ணி
having
காட்டுறியா?
any
நான்
question,
எடுத்தேன் நான்.
Revati?
எனக்கு வரலன்னு சொல்லிட்டு நான் அப்புறம் ஓப்பன் பண்ணா உன்னோடதுல தான் வருது.
Okay, let me just mute you since you are not asking anything. Perhaps you unmuted yourself by mistake. Okay, so now when we are calculating this term, we need to keep in mind that y is a constant. So y will act as a constant. Okay, so think of any constant that you can, like 2, for example. So what is the differentiation of sine term? Sine is the differentiation of sine is cosine. Let us be We know this thing. Okay, so it will be sine of xy. However, we noted that y will act as a constant. So if y acts as a constant, I need to also differentiate this inner term. If it were just x, I won't have to write here anything. However, it is x, y, and y is a constant. So you will have to write differentiation of xy. What is the differentiation of xy? If y is a constant, it
Bye.
would be just y. So it will be y cos xy, and this term here will remain as it is. Okay, plus sine of xy, this term. And what will be the differentiation of cos term? So again, what is the differentiation of cos? It is minus sine, okay, minus sine x y square. However, by the same analogy as what we used to, the same analogy that we used to write y here, what will it be? So you need to now differentiate the inner term, which is xy square. If it were just x, you would have written it just 1. However, it is not just x, it is x y square. And y is a constant because you are partially differentiating with respect to x. So it would be what? It would be just
Y
y
square.
square. Okay. Yeah. So what will this? So just writing it in a good way. I mean, neatly writing it, it will be what? X y cos of x y square, and you have a minus sign here that will come out here, so it will be minus, and it is a y square here, y square I will write it here, and sine of xy, sine of x y square. I hope this is clear. Okay, so it was just partial differentiation of some weird looking function. Nonetheless, if you just break the big thing into smaller steps, like I did here, you will not make a mistake, and you will eventually reach the correct answer. So again, let's see. So this is basically my first term. Okay, so this is gradient with respect to x of f. I hope that is clear. Now I need to calculate the second term of my vector. So remember, the main goal is to calculate this vector, of which the first term we have already calculated. However, we have to calculate the second term. So let us look at the second term. So now I have to partially differentiate it with respect to y. Okay, now y is my differentiating variable. So what will happen? Everything will remain the same, but now I will treat x as a constant, and I will treat y as a variable that I have to differentiate it with respect to. Okay, so let us see what will happen. So you have del y of uh, sine of xy times cos of xy square. Okay, so let us do a quick calculation. I will just write it. I won't elaborate it now because it's a simple thing. But if you have any doubt, you can stop me and tell me that you didn't understand something, and I will explain it for you. Okay. So differentiate the first term, keep the second term as it is. Now so keep the first term constant, which is sine of xy, and differentiate the second term, del y cos of xy square. Okay. So what will be the differentiation of this term? It is simple. It will be cos of xy. However, we have to differentiate xy as well with respect to y. Now, since xy has to be differentiated with respect to y, x will remain as constant. X will be the constant here. So it will be x, just x here. Cos of xy square plus sine of xy is already here. So what will be the differentiation of cos xy square with respect to y? So we remember that differentiation of cos is what? Sine. So sine will be here. Now I have to differentiate xy square with respect to y. So just remember that x is a constant. So x will act as a constant. I don't have to do anything with x. Now I have y square. So xy square. Okay. So think of it as 2y square. I have to differentiate 2y square with respect to y. What will it be? I know that if I have some y raised to n, the differentiation with respect to y is what? N y raised to n minus 1. We know that thing. So 2. So it will be, if I have to again differentiate 2y square with respect to y,
2y.
what will it be? 4y, right? So I am asking that, so let me just tell you del by del y with respect to 2y square. Okay. So you have to differentiate this thing. So 2 will come out as it is. Now you will have to differentiate y square. Y square will be 2y. So this will eventually become 4y. Okay. So by the same analogy, we will have 2xy here. Okay. Let me know if something is not clear. Okay. Uh, okay. So this will become what? Cos of xy, cos of xy square. So minus sign will come out, minus. You have 2xy here. Let me take this here as well, 2xy, and sine of xy square into sine of xy. Okay, this is what it will be. Okay, so if I have to write the entire term, so the first term will be what? Y cos of xy square, that we calculated when we differentiated with respect to x, sine of xy square, and this will be the second term, x cos of xy, cos of xy square minus 2xy sine of x y square, sine of xy. So, though it looks very scary, seeing this big matrix and not a matrix, but a vector and, these big terms. But you saw, right? Essentially, what you needed to know was differentiation of sine and cos. And additionally, you needed to know, okay, how to, do partial differentiation, nothing else. So it's a simple question. It is just there to, scare you. But if your basics are good, you don't need to be scared. It's a very simple thing. Okay, so let us go to the third question. What is the third question? Third question says that we have data x with the following labels. So let me write the labels here. Okay, so first is orange. Okay, so we have orange, apple, guava. Okay, three of them. Okay, right. So let me what while for the sake of saving some time, I will denote orange by O. Okay, what is there? Apple by A and guava by G. Okay, these are the three things. So now let us look at what the Y is. So Y to us is given as orange, apple, guava, orange, apple, orange, apple. Okay, this is what is given to us. And we are asked that which of the following distribution will give the lowest cross entropy loss with Y. So just remember that what is the cross entropy loss? Cross entropy loss is the following, right? You have a negative summation over what? You have yi. So this is y. Okay, yi log of yi hat. Okay, so yi is the true. This is the true label. Okay, this is the true. What do you call it? It is the uh, true distribution. Okay, true distribution, and yi hat is the predicted distribution. Predicted distribution. I hope you remember these things. Okay. And
Actual values, right? It is also called actual values and
which
predicted
one?
values. True
Yeah.
distribution is
This is
given
also
as
called,
actual.
yeah. Right. So this is called as actual values. So yeah, I mean, it is just a change of, uh, what do you call it? So, so yeah, I mean, you are correct. This is also called as true labels. Let me tell you a few more and predicted labels. So there are different names to these things, but you should know what the essence is. Okay, so essence is that here you have the true values, whatever true distribution, true value, actual value, whatever you call it, and here you have the predicted values, predicted distribution or predicted labels, whatever you call it. Okay, so this is the cross entropy loss. Okay, and I hope that you remember from the lectures that minimum minimum value of LCE, the cross entropy loss, is what? It is zero. Okay, so the minimum value that the cross entropy loss can take is zero. Okay, so in other word, if I have to write it mathematically, LCE is always greater than or equal to zero. So the lowest value, let me write it, min of LCE, what is it? It is zero. So, and we are asked that which of the following distribution will give us the lowest cross entropy loss with Y. Okay, so which of the following will give the lowest cross entropy? So if you remember, again, let me, it was there in lectures, I hope. I mean, if not, I will tell you the the minimum, this min value is attained when yi is equal to yi hat. Okay, so basically what we are saying is the very simple thing. Okay, what we are saying is that, okay, the predicted value is same as the actual value. This cross entropy will attain the lowest value, and that is what is desired, right? We want that our predicted values should be close to the actual values. That is what we desire as well. So now we know that, okay, for this y, okay, for this y, if I am able to find its actual value or the true distribution, that will be the distribution which will give me the minimum value of the cross entropy loss, which is nothing but 0. So when will that happen? Okay, so what is the true distribution? True distribution, true distribution slash actual value. What is it? So it's simple. Okay, so what you have to do is nothing. So let me just copy this. Okay. Copy this thing from here, paste it here. Okay. Okay, so what is it? So let us calculate it. Right? So there are three possible outputs: orange, apple, and guava. Okay, that we are clear. So what is the probability of orange? So let us count. It is a simple counting thing. So you have one, two, three, four. Four of them are orange. Okay, four of them. And how many total are there? One, two, three, four, five, six, seven, eight. Eight of them. Okay, fine. Okay, now what is the probability of apple? So how many of them are apple now? So let us again count. One, two, three. Three of them are apples. Okay, so 3 by 8. What is the probability of guava? Oh, we only have one guava. Sad, but nonetheless, what can we do? 1 by. Okay, so if my yi hat, so yi for me is 4 by 8. What? 3 by 8 uh, and 1 by 8. And I know that if my yi hat is equal to the same value, the value of cross entropy for me will be 0 and I will attain the minimum value. Okay. So this should be my answer, right? 4 by 8, 3 by 8, 1 by 8. And what are these values approximately? 4 by 8 is 1 by 2, which is 0.5. What is 3 by 8? 3 by 8 is what? 0.38 to the 16, it's 24. 608, I don't know, 8 8 is 64, some 7, something like this. And 1 by 8 is what? So 0.1 to 8 to the 16, something like this. So whatever is closest to this will be the answer. So I think the first option is 0.5, 0.375, and 0.125. So that looks like the correct answer. The second option is 0.56, 0.31, and 0.11. Okay, so if you get some option like this, no, you can just check if the sum of these numbers are equal to 1 or not. So 0.56 plus 0.31 plus 0.11, I think is less than 1. So let me think about it. So 0.31 plus 0.11 is 0.42, and 0.42 plus 0.56 will be 0.97. So if the sum is not equal to 1, then it is definitely a wrong answer. And other options are also not correct. You can just see that this is the correct answer. Okay, so this is the A option in the assignment. All right, so we have completed third question. If you have any question, okay, just a second. Yeah, so if you have any question, you can just ask me. Okay. Let me check. Okay. This is good. All right. So what is the next question? So I hope you can see that these questions are not tough. Okay. In my opinion, these are very easy questions. The only way you can make mistake is by, if your basics are not, if there is some flaw in your basics, only then you will face some problem. Otherwise, they are very easy questions. Okay. So what is the fourth to sixth question? Okay. So you have been given some data. What is the data? You have been given a feed-forward neural network for a classification problem. Uh, okay, and there are some yellow nodes that represent the bias. Okay, how should I then draw it here? It's difficult for me. Okay, let me try something. What I will do is, it will take a lot of time though. Let me just draw it. Okay, what the hell? One, two. Sorry. Let me start from some below. Do it from here. So there are four here. One, two, three, four. There are 8 plus 1, 9 here in the first layer. One, two, three, four, five, six, 7, 8, and 9. Again 9 in the other one. One, two, three, four, five, six, 7, 8, 9, and 3 in the final one. 2, 3. And these are connected. Okay, so you can just imagine some connection there, but I won't be able to draw that. Okay, it's difficult for so these yellow ones I have highlighted by this yellow color. So these are not to be counted, is what they have said. Okay. So the fourth question asks you that how many bias parameters are needed to be learned by our network. So how many bias parameters? Okay. So let us count them. Okay. So I hope you remember that each. So let me just draw one of them. So this connection will have one bias term. This connection will have another bias term. This will have another bias. Or no. I am not correctly saying that. So how many bias term will be there? Okay. So what will happen is so 8 plus 8, 16. Am I correctly counting them? Uh, 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 uh. Yeah. So right. So there will be what? Mm, three of them will be here. 8 of them will be here. Yeah, correct. So the answer would be so okay. The following will hold. Okay. Okay. So I was just thinking aloud. Okay. So these connections, right? This connection, this connection, this connection. So till what? This connection. All of these connections will have one bias term. I hope you agree with me. All of them will have one connection. Let's say B1. Okay. The second neuron will have one connection. So it will have another connection that I am representing by purple. Okay. This till the last one, which is this one. Okay. And so this will again have another bias term, which is let's say B2. And the third neuron will have again similar connections, right? Something like this till last one, which is this one. Okay. So it will again have another bias term, let's say B3. So I hope you can see that if you have three neurons here, you have three bias term B1, B2, and B3. By similar logic, this will be connected to all of these, and these connections will have another bias term which we will call B4. Again, similar to that, we will have another connection from the second neuron. All of these will have, let's say B5. And similarly, like each of these neurons on the first layer will have their own bias terms. So how many bias terms will be in the second layer? So let me just count it. Okay. So here it was three. By similar logic, I hope you can see that you have eight neurons here. So you will have eight bias terms here. Okay. So uh, eight of them here. And similarly, you will have connections here like this. Okay. So this will have one bias term. This will be connected to these. This will have another bias term. By similar logic, the number of bias term will be equal to the number of neurons. Which here is what? 8. So you have again 8 neurons here. Okay. So these are 8 in number. So again you will have what? 8 neurons here. So the total number of bias terms is what? 3 plus 8 plus 8, which is 19, which is your fourth option. I hope this was clear. If not, you can just unmute yourself and ask questions. Okay. So the fifth question asks you the number of weight parameters. Number of weight, how many weight parameters are there? So let me, erase this thing. Do I need to erase this thing? Yeah, I think I will have to erase this thing. How do I erase it? Let me try. Okay, okay, good. Okay, fine. So let me draw that diagram again, but this time I will count the number of weight parameters. Okay. So I hope you remember that this neuron will have one weight. This connection will have one weight. Let's call it W11. This neuron will have another. This connection will have second weight W12. Similarly W13 and till what? This is eighth one, right? So this is the W18. Similarly, when I do this connection, I will have what? Another weight parameter, W21. When I do this connection, I will have W22. And similarly, when I come till here, it will be what? Uh, W28. So how many so and similarly, like when I do it this time from this one, this will be what? W31, W32 till what? This last one will be W38. So what is the total number of weight parameters that we are seeing? So each of them had 8, okay, and there are three such, so 8 into 3, which is what? 24. And I hope you will agree that I can calculate the number of weight parameters by just multiplying the number of neurons that are here and the number of neurons that are here. So here were 8 neurons. I had 3 neurons here. So 8 cross 3 was 24. Similarly, I have 8 neurons here and I have 8 neurons here. So how many weight parameters will I have? Very simple calculation, 8 cross 8, which is 64. And similarly, I have 3 neurons here and 8 neurons here. How many weight parameters like this will I have? Again, a simple calculation, 3 cross 8,
It's 24.
24, right? So I mean, whenever you are asked to calculate the number of weight parameters at, let's say, this level, just see how many neurons are here, how many neurons are here, and just multiply them. That is the shortcut. So what will it become? So let me write this down. So this was 3. So this was 8 into 3 plus 8 into 8 plus 3 into 8, which is what? 24 plus 8 is the 64 plus 8 is the 24. What will this become? 64 plus 48.
112.
So okay, 112. Thank you. So I think 112 will be the correct answer. I hope you understood the solution. If not, you can just unmute yourself and ask your doubt. Okay. So what is the next question? The sixth question asks you which loss and activation function for the output layer is best suited for the above given network. All right. So let us look at our network. So okay, it was a feed forward network, right? Okay, that is fine. What was it supposed to do? It was supposed to do a classification problem. Classification. So the end goal of this network was to do classification, or what else? Nothing else is given. Okay. And what are the options that are given to us now? So whenever there is MCQ, right? Don't don't try to come up with the correct answer. Just first try to see if you can manage with the given options itself. Because with the given options you can most of the options you can nullify that they are definitely wrong, and basically that those you use MCQ shortcuts that you can. So what is the first option that is given? Which loss and activation function? So first option is squared loss, comma, linear activation function. Okay, why would this not work? We discussed earlier, right, that linear activation is not a good choice. But let's say even if you did, squared loss is not something that you can use for classification task. Why? Because squared loss expects so classification in some sense wants you to match the distribution, the actual values and the correct values. Correct squared loss won't do that. Okay, so let me just write it down. Squared loss not used for classification. I will write just CLF. Linear activation is not good, not used for CLF. So I think, if I don't know when did you join, but we had discussed the problems with linear function here. So if you missed that, maybe when this lecture will be shared with you, you can go back and see what are the issues with linear functions. Okay. All right. So let me go down. So what is the second option? Okay. So I hope this is wrong. Right. This is not correct. Let us see the second option: accuracy and logistic. Okay. Okay. Why is this not correct? You can just see, right? You were given what? How many outputs were there? There were three outputs. Logistic function, how many outputs can it handle? Just two outputs, right? This is used for binary classification, not for three or multi-class classification. And accuracy for, I mean, accuracy is not the activation function. Okay, it's not a activation function. It is a metric. It is a metric that we use to see if the correction the classification was correct or not, but it is not an activation function as such. What is the third thing? Cross entropy and logistic. Okay, now we are happy that we saw cross entropy, because just now we had seen that okay, cross entropy is something that is very helpful in classification. But there is something else that we need to check. This is logistic that is given to us. Is logistic good? Well, well, logistic is not good because we just discussed it, right? It can be used only for binary classification, not for multi-class classification. Just to brush up your memory, here is the logistic function. This was 1, this was 0, and something like this was your logistic function, right? So there were only two levels, 0 and 1. Whereas we need a 0, 1, and a 2 also. Where is the 2? We don't know where the 2 is because logistic function doesn't provide that. Whereas the fourth option, which tells you cross entropy and softmax. So this is something that works. Softmax actually provides you this third level as well, right? Again, if you didn't follow why it is good, just go back in the lecture. I had discussed it here. Okay, why softmax is good. So okay, so I mean, long story short, this is wrong. This is wrong. This is also wrong. This is correct. Okay. Okay. What is the seventh problem? Okay, let us see. The seventh problem is the probability of all events x1 to xn. So, okay, so there are some events x1, x2 till xn. N is greater than 1 is given to us. So, if n is greater than 1, what can n be? N can be equal to 2, 3, 4, whatever, like infinity to infinity. Okay. What can you say about the entropy h of x of that system? And the base is log 2. Okay, we are hearing some weird things now, right? What is entropy? Entropy. Maybe you have seen, if you have seen the lecture, it is denoted by h of x. What is it? It is negative summation, summation pi. So let me write it like p of xi log of what? 1 upon p of xi. Or this is also written as summation p of xi log of p of xi, right? This is also a valid statement. Okay. I have what? How is it obtained? Just take the negative thing inside, and you will get it. Okay. So it is given that all events are equal. All events are equally likely. Equally likely. Or in the question it is written that probability of all events are equal. The another way to say it is that they are equally likely. So what? How? So now, what information can I get from it? So now I know that p of x1 plus p of x2 plus all these things p of xn should be equal to 1, because the sum of probabilities is 1. Okay. Now I know that each of them is equal. If each of them is equal, how? So let me say that okay, p of x1 is equal to p of x2 is equal to some p of xn, which is equal to, let's say, p. I know that all of them are equal, so I can take any value, let's say p. So p, how many times will it be added? N times. P into n is equal to 1, right? So what will be p? P is nothing but 1 by n. right? So this is a simple calculation, right? Now I know what P of xi is. For each xi, the P of xi is P, which is equal to 1 by n. This is also equal to 1 by n. So I can now calculate the entropy. So h of x will be what? Negative, so let me use the other thing, summation 1 by n log of 1 by n, right? Okay, this is correct, right? Uh, I hope so. Uh, okay, I think there is a plus sign here and negative sign here. Is that correct? I think so. So I think there will be a negative sign here. So just check whether the positive. I think this is correct. Yeah, I think this is fine. So this is the value. Okay. So there is just an ambiguity whether the positive sign is here or negative sign. But nonetheless, I think this is correct. Okay. This is what it should be. So what will this be? This will be, well, so let me just change few things. So I know that this is what I equal to 1 to n, right? So I see that the term that is inside here doesn't depend on I. So there is no I term because all of the pxi's were equal and they were equal to 1 by n. There is no dependence on I anymore. So this is like a constant. Okay, sorry. This is like a constant and I can take it outside. So this is, I hope you will agree that this is a constant. I can take this outside and what will it become? So I can write something like this. So something like this I can write. So what will it become? Negative 1 by n log 1 by n summation I equal to 1 to n 1. There is nothing but 1 here, right? Because I have taken everything outside. So I can take this negative sign inside the log. What will it become? Log of n, right? Log of 1 by n. I take the negative side inside. So minus 1 will come here and it will become log of n. And upon n into summation of 1 I equal to 1 to n. What is this value equal to? This value is equal to n, right? So you are adding 1 n times. So let's say n is equal to 2. 1 plus 1. What will it be? 2. If n is 3, 1 plus 1 plus 1 equal to 3. I hope that is clear. So this will be log of n by n into n. This will get cancelled. This is what? Log. We are given that the base of log is 2 and that is n. So now this is the thing, okay? And earlier we had seen here, right, that what are the possible values of n that it can take? 2, 3, 4 till infinity, right? So let me write it here. N is equal to 2, 3, something like this. Any one of these values. So if n is equal to 2, what will it be? Log 2 of n. Log 2 of 2. This will be 1, right? I hope you know basic logarithm. Okay. Okay. N is equal to 3. What will it be? Log 2, 3. I don't know. It is something like 1.7 if I remember correctly. N is equal to 4. So, and you cannot write everything. I hope you can see because there are many values here. So in these cases, what should you do? You should just plot the log graph. Okay. The graph of log is something like this, right? Something like this. So you see it is always increasing. Its value is always increasing in y-axis. So when the value of n is 1, the value is 2. Whereas if the value of n is 2, it corresponds to 1. Okay. And I can now see that if I keep increasing my n, so this is the n. If I keep increasing my n, it will only take values that are greater than 1, right? So it can only take values that are above 1. So I hope you will agree that h of x, which is equal to log 2 of n, will only be greater than equal to 1 if n is greater than 1 or n is from in this set 2, 3, things like that. Okay. I hope this is clear. If not, you can ask question. Okay. Don't hesitate. Okay. So yeah. So the final answer should be h of x is greater than or equal to 1. Okay. What is the eighth question? Eighth question says that, suppose we have a problem where data x and label y are related by y is equal to x square plus 1. Which of the following is not a good choice for the activation function in the hidden layer if the activation function at the output layer is linear? Okay. So, and the options are, let me write the options. As I said, these are MCQs. Just use the options that you are given to, uh, kind of get the correct answer quickly. Okay, sigmoid. And third is tan inverse of x. Okay. So, okay. So, what is the issue? Let me just elaborate the issue here. Okay. So, this is a good problem actually. So how will this curve look like? I hope you remember how y equal to x square. If this is 1, this will be y equal to x square plus 1. Something like this is the curve. Now, suppose you have your some one input is there x. You have some uh, feed forward network, and you have a final output y. So this will be connected here, right? This will be connected here. Right? So how? So let us think of one hidden layer case, right? So let's say the weight matrix here is like something like W1 and W2. So I hope you remember the output of this layer will be what? Some activation function G of W1 uh, W1x plus some bias term B1, let's say. You will multiply this by W2, add some bias term B2, and again pass it to some G. Something like this. So, but okay, so there is no activation function in the if the activation okay the it is given that the activation function at output. So this is what it will be. So right, this is what you are trying to approximate it with. If anyone has problem here, maybe you can just ask me right away because this is some basic, very basic thing. Okay. So G is your activation function. Activation function. So let us think of it, right? So so if I use, a linear layer, linear activation function, what will it become? This will become W times linear activation will give you what the input is. If so if G is linear, then G of x will be nothing but x. So it's like whatever comes as input, it gives that as output. So if W1x plus B is input, it will give that as output plus B2. What will this become? W2 W1x plus W2 B1 plus B2. Right? I am just simplifying this. I hope that is clear. So now I can club these two W's and use. I say like, okay, this is some W. The W is W2 times W1. Wx plus, and I will call this as B, where B is W2 B1 plus B2. Okay. Oh well, now it turns out that if I use linear activation function, what I will get is a something like this Wx plus B type of form, which is again linear, right? This is linear. What is the issue with it? Let us look at it. So the function that I want to approximate is quadratic. It is not linear. However, the function that I am approximating it with is linear. Do you see the problem? That I am trying to approximate a quadratic function using a linear function. A quadratic function with a linear function. Will I be able to, ever approximate it? Well, no, right? I hope you can see that. I cannot approximate a quadratic function with a linear function. It is not possible at all. So cannot use linear activation. So I need to have some non-linearities in my uh, activation function, and all these other options here, right? All are like all of them are non-linear. So ReLU function, it takes how does ReLU function look? It is 0 till 0 and it goes to 1 like this. You will say that, oh look, you said that it should not be linear, but this is linear. Well, it is linear on this side and it is linear on this side. However, overall this function is not linear. There is non-linearity here. Okay, and that is enough. I just want some non-linearity. If it comes in this form, I am happy with it. Okay, again, sigmoid, if you remember, sigmoid is also something like this. Okay, something like this. Tan inverse is also something like this. Okay, so all of these are non-linear. However, linear function is actually linear, something like this. That won't work for us. Why it won't work for us? Because of this observation that, eventually you are just approximating a y equal to x square kind of function with a y equal to x type of function, which is not desired. If you have if you have any questions, you can just ask me. Okay, so it is 6:15. I need to leave early today, but I will try to complete these things as soon as possible. Okay, so the ninth question is, which of the following state in which of the following steps in the proper order constitute the training of feed forward algorithm? So let us see. So I will use short forms. So first option is backward, forward, and wait update WU. Second option is forward, wait update, and backward. Third option is forward, backward, wait update. So my U is looking like W. Okay. And fourth is backward, wait, update, forward. So this is a very easy question. Uh, uh, so let me just tell you. So first of all, what happens is when there is some input, there are some inputs, there are some hidden layers here, and there is some output. Okay. First, you give the data as input. Okay, this is the data. This goes forward first. So any option which first takes backward this and this, they are wrong, right? These are wrong. So immediately you can say that these are incorrect options. So let me just mark them up. These are not correct. There are two options which have forward in the first step. Okay, those might be correct. Okay. Okay, so what happens? Let us again come back. So this is the input. You first do a forward pass. You pass it through the network. Then you calculate the loss function here. What is the loss function? Then you what you do is you do a backward pass. Okay, and up in the backward pass, what do? You calculate the gradients using chain rule. I hope you remember how we did it in class. So you go forward, calculate the loss, calculate the gradient of the loss with respect to parameters, and then update the network parameters. Okay. So the right order is you go forward, go backward, and then update. Okay. So update all the parameters. So this is the option that says that. Okay. So this is incorrect. This is the correct option. You go forward, come back, and update the parameters. Okay, if you have any question again, then please ask. Okay, uh, that will be good. Okay, so here is the 10th problem. We are given that probability of event A happening is 0.85. Probability of event A is 0.85. Okay, probability of event B is given to be 0.05. Which of the following statement is true? Okay, so, okay, first of all, what does information mean? We don't know, right? I mean, there is no close form solve. But one way to define information is anything.
En- Entropy?
Yeah.
Would it be entropy?
No, so entropy is not a measure of information, right? It is a measure of randomness in the system. Okay. I mean, information is an abstract term. Okay, we don't know what exactly constitutes information. So, for example, if I tell you, okay, so okay, so let me give you an example. Okay, so suppose there is a coin. On both the sides of the coin, you have heads. Okay, so you have heads, comma heads. All right. So and if I ask you that, okay, toss the coin. Okay, so you toss the coin. Okay, you get something. So would I need to know what your output is to tell what the actual output is? No, right? Because I know since both the sides of the coins was head, there is no chance that you can get anything other than head. Was that clear? I don't know.
Yes, yes.
Right? So I hope you get my point that, if there is nothing uncertain about the event, right? There is nothing random, then it doesn't really mean what information is. There is no information present here in some sense. No uncertainty, right? However, let's say there are two sides and one side is heads and other side is tails. And I tell you that, okay, probability of heads is, let's say, 0.6 and probability of tails is 0.4. Now there is some uncertainty involved. Okay, I mean, it can be heads or tails. Okay, anything can happen. However, now if you tell me, right, that this is the probability, you have given me some information, right? Here you do anything, you cannot change the outcome that is going to happen. It is always going to be heads. However, in this case, you have given me some information, and that information is this probability. Now if you ask me, so if I again give you the coin and you toss the coin, and I have to get some bet that, okay, whether it is going to be heads or is it going to be tails. Now I can, safely, I cannot have a safe bet anymore. But since the probability of heads is slightly bigger, maybe I will say that, okay, heads is what you have got. Why am I saying it is heads? Because you have given me this information that, the probabilities are such and such. I hope I am making sense. If not, please tell me. Okay. So what I was writing was, information can be said as anything that reduces uncertainty. Uncertainty. Okay. So anything that reduces uncertainty. In this case, it was the probability of heads and tails. That can be categorized as, can be usually termed as information. Okay. Okay. So let us now have a look at the so from this inform so we have been given this information. How do I calculate the how do I say which thing has more information? Well, the formula for this is, let me write that down. So it's not exactly information, but loosely saying that, I of A will be is termed as log of 1 upon 0.85. So I of any event E, it is log of 1 over P of E. That is how it is defined. Why it is defined so? Think of it like this. Okay, so if the probability of E is equal to 1, okay, is there any information in, for example, in this case, the probability of heads was 1. Okay, so if I substitute it here, what will it become? Log of 1 by 1, which is this, which is what? It is log of 1, which is what? Again 0. So there is no information actually. I hope you can see here, right? However, here that won't be the case, because heads has different information, tails has some different information, and you can calculate using this formula how much information is in each of these events. So for in our case, in this case, A has the following information, which will be what? Log of 100 by 85. I don't know what this number is, but let it be. Similarly, I of P would be what? Log of 1 over 0.05, which is what? Log of 100 over 5. Now, which one of these is big? Let me try to do that. So 85 twos is what? 160, 170. So it won't go till, it will be 1 point something x. Let me write that as something like this. However, what is this? Log of 20. 5, 4, 5 20 is 100. So I hope you remember the graph that we plotted earlier, right? So this was your curve, this was one, and this was your log. So this thing is somewhere between one and two here. Something. Okay, let me use some other color. So it was something like here. Okay. So this is what I of A was. However, 20 is somewhere here, very far from here. Okay, and the curve is going like this. So what will that correspond to? Something over here, right? So which is I of B. So clearly, let me write it clearly. I of B is greater than I of A. What does it mean? A has low information, low info, and B has high info. In particular, okay, whenever the probability of an event is low, it has high probability. I hope it is clear from this formula. When the denominator will be low, this entire term will be high. And what it tells you is that some uncertain events. So if the so if the information of a event is very high, for example like this, there is no information as such. However, if you tell me that okay, no, there is some probability with which something else can happen, that actually gives you information in true sense. So that is why these kind of information and these things are happening. Okay, so if there are any questions, you can ask me. Otherwise, we have solved all 10 questions, and we will quit here. Okay, so if there are any questions, please ask. Uh, Otherwise, yeah,
May I, Geetika?
yeah, 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 sure.
Actually, when I calculated entropy, it came out to be zero point zero 0.05 and zero point zero 0.06. So I think even that is giving us the same answer. 0.05 and
Okay,
0.06.
okay, 06 is it? This thing.
Right.
Well, I mean, entropy.
Since
Well,
entropy is
entropy is yeah, yeah, yeah. Entropy is not a good measure. Okay, let me tell you why. Okay, so let me calculate. So let's say probability of heads for an event is what? Let's say 0.6. Okay, probability of tails is what? 0.4. Okay, let me calculate the event entropy of this thing. Okay, you must have calculated it something like this, right? 0.6 log 0.6 plus 0.4 log 0.4. Is that correct? And here it will be 0.4 log 0.4 plus 0.6 log 0.6. Is that correct? Is that how? Sorry. Okay. Kritika was somehow. So is this how you had calculated your entropy? If I am not correct, if I am not wrong, this is how you would have calculated it, right?
I'm sorry, actually I lost my connection. I couldn't see it.
Yeah, yeah.
Get
Let
it.
me repeat it.
Okay. Also,
Yeah,
your
yeah. Let
screen
me
is
repeat
not
that.
visible.
Okay. Let me again stop sharing and reshare it. Is it visible now?
Yes, thank you.
Yeah. So I was saying, suppose you have a heads and tails, and probability of heads is 0.6 and probability of tails is 0.4. Okay. So as you were saying that, okay, entropy is equivalent, entropy can also tell you the information. So let's see, in this case, if you have heads probability 0.6, what will be the entropy here? I hope you would agree that this will be the entropy, right? Zero point 0.6 like log zero point 0.6 plus zero point 0.4 log zero point 0.4. And for
So
tails, the entropy would
we
be,
can we can actually calculate it as minus sigma px log px. So it will be minus
yeah,
0.6
yeah,
log.
yeah, the negative of this, yeah, okay, something.
In that case, zero point 0.4 log zero point 0.4 is not required, I think. because since we are using minus sigma px log px, it will
Oh
simply
no,
be.
then you are not correcting. Yeah, yeah. So if that is the case, if that is how you had calculated, then that is not the correct way to calculate. If you are, so if
Okay.
only one thing is given, right, you have to calculate it like 0. So let me write the general form. So if only one thing is given, the way to calculate entropy is P log P plus 1 minus P log 1 minus P, and take the negative of it like this. So the way you had calculated it was wrong. Okay, this is how you should have calculated it then. Am I clear?
Okay, I think wouldn't it come out to be that only minus sigma minus px log of px? Will it
Yeah,
not
yeah,
come?
that is exactly, yeah, yeah, correct. That is exactly what this is actually. But you were saying that you just used this thing, right? Just the first term.
If we have to find out the entropy for the first case wherein probability is given zero
Hmm.
point 0.6, then we will find
Yeah,
out the entropy as minus zero point 0.6 log of zero point 0.6, and for case 2 it will be zero point 0.4 log of zero point 0.4. I mean
yeah,
minus
that is what
2.
I'm saying. Yeah, that is what I'm saying, that it is not the correct way to calculate, because just, so you are saying this, right? Just take P log P. If it were P, you are saying that just take minus P log P, right? But I am saying that that is not the correct way to calculate the entropy, because there is a second event as well, right? Which is the complement of this, which will have 1 minus P probability. So, so whenever you are calculating this entropy, right? Pi log Pi, there is a condition that summation Pi should be equal to 1, right? In that case, just taking minus 0.6 log 0.6 won't suffice, because 0.6 is less than 1. Its sum is not equal. Can you see that? Uh, is that clear?
Yes, somehow I'll try it one more time and check. But what my understanding was that they are two different events, and that is why I took them separately.
Yeah, so actually you should have used this formula, but nonetheless, if you got correct answer, that I'm not saying that, okay, I mean the answer is wrong, but the way that you calculated was not correct. This is how log 1 by P is what you should use to calculate the information in an event.
Okay, sure. Thank you. Also, we have another session today. It's mentioned. So, will be taking the same? Will you be taking the same assignment 3, or will be continuing with another assignment 4?
No, so I won't be taking that. I think that session is postponed, if I am not wrong, uh, because I think you might check your the NPTEL forum and your mail, because there was some issue with the other session, and I think it got postponed to 20th February. So I think this is the only session that will happen today. There won't be any more session.
So, when there are in future, when there will be two sessions in a day, that means we'll be taking two assignments, like two consecutive assignments.
No, no, no. I will be taking only one assignment. The other TAs will be taking other assignments.
Okay, okay, okay. Thank you
Yeah.
so much for the session. It was really wonderful. I attended it for the first time. Thank you so much.
Okay. Thank you. Thank you. Thanks a lot. Okay. Any other questions? If not, we will leave the meeting. I also have some work to do. So this was also kind of, I took it very fast. If you notice, the pace was fast today. Nonetheless, if you have any questions, let me know. If not, we can end it here.
No, I think actually it was perfect the way it should be. Thank you so much for taking the session for us.
Okay. Glad that you liked it. Okay. 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 So someone is saying clearly explained. Okay. Thank you. So, all right. I mean, this is also like first time I'm taking NPTEL sessions. I, your feedbacks are valued. If there are any feedbacks, that is also welcome. Okay. So, okay. So, if there are no questions, then I think we can end the meeting. So, I will end the meeting. Thank you everyone for attending it. Yeah. See you. See you next time. Okay. Bye.